before you knew your own name, before you knew the word for hunger or warmth or safe, before any of the frameworks you use to understand the world had assembled themselves in your mind. There was milk, warm, white, and given without being asked for. The first thing the body ever received. The original comfort, older than memory, older than language, built into the biology of every mammal that has ever lived. Tonight, we are going back to that, all the way back. If this is how you end your nights, please hit subscribe right now so you never miss one of these. Tap the like button to help someone else find this tonight, and drop a comment telling us where in the world you are watching from and what time it is there. We love knowing who is with us. Now, let's begin in the quiet. It is late, and the kitchen is dark except for the small light above the stove, the one that stays on because complete darkness in a kitchen feels slightly wrong. The counter is cool under your hand. On it, a glass of milk, whole milk, warmed just past room temperature, not hot, the way it never quite manages to be in a microwave, but warm in the way things are warm when someone has paid attention to the warming. A thin curl of steam rises from the surface and disappears into the dark air above it. You have been here before, not in this kitchen, not at this exact hour, but in the feeling of it. Something about a warm glass of milk in a quiet, dark room touches a part of the nervous system that is not accessible to most adult experiences. It does not feel like comfort in the way a good meal feels like comfort, or the way a hot bath does. It feels older than that, less chosen, more fundamental. There is a reason for this, and it goes all the way down to the biology. Milk is the first food every mammal on Earth has ever tasted. Not a variation on milk, not something milk-like. Milk itself, produced by the body of the mother and given to the body of the young, in an act so fundamental to mammalian life that the entire class of animals is named for it. Mammalia, the milk givers. 300 million years of evolution, and the first thing every new life in this lineage receives is the same white liquid, produced by a body that has reorganized itself specifically to make it. The blue whale calf in the cold ocean, the elephant calf on the warm savanna, the mouse pup in the dark of its nest, the human infant in the first minutes of its life outside the womb. Each of them receives, as the first transaction with the world, something warm and white and exactly calibrated to what their body needs at that precise moment. No other food will ever be that specifically made for them again, and the body remembers this, not consciously, not in the way you remember a meal or a conversation or a place. The memory sits in the deeper layers of the nervous system, in the parts of the brain that process safety and warmth and nourishment at a level below thought. When those signals arrive again in adulthood, the warmth, the particular chemistry of milk, the act of being still and receiving something in the body responds to them with a recognition that does not need to be explained or understood. It simply knows. This is why the warm milk before bed is not a myth, not a placebo, not a grandmother's well-meaning but unscientific advice. It is the oldest sleep signal the mammalian body knows. It arrives through the mouth and moves through the blood and speaks to the nervous system in a language older than any words we have ever used to describe what we feel when we drink it. We are going to spend tonight inside that language, inside the biology and the chemistry and the 10,000 years of human history that are present in a single glass of warm milk on a dark kitchen counter. We are going to go slowly. There is nowhere to be. The steam rises. The kitchen is quiet. And somewhere in your body, something very old is already beginning to remember. Most people, if asked what milk is, would say something like, a white liquid that comes from cows. And that is not wrong. But it is approximately as accurate as describing the ocean as a large amount of salty water. Technically true, completely missing the point. Milk is one of the most complex biological fluids ever produced by a living body. More complex than blood in some respects. More deliberately engineered, in the evolutionary sense, than almost any other substance the body makes. It did not evolve to be simple. It evolved to do something extraordinarily difficult. Take a new life, one that has just arrived in the world with nothing. No immunity, no reserves, no capacity to find or process food on its own, and sustain it completely through the most vulnerable period of its existence. Everything in milk is there to serve this purpose. Nothing in it is accidental. The fat content provides calories, dense, efficient, immediately usable energy for a body that is growing at a rate it will never match again in its life. The fat also carries fat-soluble vitamins that the newborn body needs and cannot synthesize on its own. It carries hormones that regulate growth. It carries bioactive lipids that influence the development of the brain. The fat in milk is not filler. It is a delivery vehicle for a long list of things the young body cannot yet make for itself. The proteins come in two main families. Caseins, which make up about 80% of milk protein, form structures called micelles, tiny spherical clusters that hold calcium and phosphorus in a form that can be absorbed by the gut rather than simply passing through. Casein is how milk delivers the minerals that build bone without those minerals crystallizing out of solution and becoming useless. It is a solubility problem that the body solved by wrapping the minerals in protein. And it is a solution so elegant that food scientists have spent decades trying to replicate it for supplements and pharmaceuticals. The remaining 20% of milk protein is whey, a collection of proteins with their own separate roles. Some are structural, some are enzymes, some are immunoglobulins, antibodies produced by the mother and transferred directly to the young through the milk, providing a borrowed immunity that bridges the gap between birth and the point when the infant's own immune system is capable of generating its own defenses. The mother is, in a literal sense, lending her immune history to her young through milk. Every pathogen she has encountered and overcome, every antibody she has made, passes in some concentration into the milk, and from the milk into the body of the new life she is feeding. The sugar in milk is lactose, a disaccharide found almost exclusively in milk, produced nowhere else in nature in any significant quantity. It is digested more slowly than simple sugars, providing a steadier release of energy rather than a spike. It also feeds specific beneficial bacteria in the infant gut, promoting the development of a microbiome that will influence health outcomes for the rest of that animal's life. The sugar in milk is not just fuel, it is infrastructure. And then there are the hundreds of minor components: hormones, growth factors, cytokines, oligosaccharides, nucleotides, each one present in small amounts, each one with a specific role in the development and maintenance of the young body. Some of these compounds have been studied in detail. Many have been identified but not yet fully understood. There are almost certainly components of milk that have not yet been characterized at all, doing jobs we do not yet know need to be done. All of this suspended in water, in a fluid that pours from a glass and warms in a few seconds in a pan, and has been part of human daily life for so long that we barely notice it. The glass on the counter is not simple. It never was. It is one of the most sophisticated things a living body has ever made. And it was made from the very beginning specifically for you. The warm milk before bed is one of the oldest folk remedies in the world. It appears in the domestic traditions of cultures across Europe, Asia, and the Middle East, passed from generation to generation, long before anyone had the biochemical vocabulary to explain why it worked. Grandmothers recommended it. Doctors occasionally dismissed it. The people who drank it kept drinking it. The grandmothers were right. Milk contains tryptophan. This is the starting point for understanding why milk and sleep are so consistently linked across so many different human cultures and such a long stretch of human time. Tryptophan is an essential amino acid. Essential meaning the body cannot make it and must obtain it from food. And it is the biochemical precursor to two of the most important molecules in the human sleep and mood system. The first is serotonin. Tryptophan is converted in the brain into serotonin, the neurotransmitter most associated with feelings of calm, contentment, and emotional stability. And serotonin does not cause sleep directly, but it creates the neurochemical conditions that make sleep possible. The quieting of the anxious, problem-solving, future-projecting activity that keeps the mind active when the body is ready to rest. The brain needs serotonin to stop talking to itself at the volume it maintains during the day. The second is melatonin. Serotonin is itself the precursor to melatonin, the hormone that regulates the sleep-wake cycle, that rises in the bloodstream as the light fades in the evening and signals the body that it is time to prepare for sleep. Melatonin does not force sleep the way a sedative does. It communicates permission. It tells the body that the conditions for rest are met, that the timing is right, that the transition can begin. The tryptophan in milk is the beginning of this chain. Drink warm milk, absorb tryptophan, convert it to serotonin, convert serotonin to melatonin, receive the signal to sleep. The folk remedy works because it is delivering a precursor to the exact molecule the body uses to initiate its own natural sleep process. It is not overriding the system or sedating it. It is feeding it what it needs to do, what it already knows how to do. But tryptophan is not the only sleep-relevant chemistry in milk. The proteins in milk, particularly the caseins, are broken down during digestion into smaller fragments called peptides. And some of these peptides have mild relaxing properties of their own. A group of compounds called casein-derived bioactive peptides, particularly alpha-casozepine, binds to the same receptors in the brain that are targeted by benzodiazepine drugs, the class of medications used to treat anxiety and insomnia. The effect of casein peptides is far weaker than any pharmaceutical, and that is precisely the point. It is a gentle, body-natural signal, a whisper to the nervous system rather than a command. The calcium in milk adds another layer. Calcium plays a direct role in the brain's ability to use tryptophan to make melatonin. Low calcium levels are associated with disrupted sleep. Adequate calcium helps the brain run the tryptophan to melatonin conversion efficiently. The milk is not only delivering tryptophan, it is delivering the mineral the brain needs to process that tryptophan correctly. And then there is the warmth. A warm beverage raises the core body temperature slightly, and it is the subsequent drop in core temperature as the warmth dissipates that the body associates with sleep onset. Cooling after warmth is one of the body's primary physiological signals that sleep conditions are met. The warm milk does this through chemistry and through temperature simultaneously. A two-track delivery of exactly the signals the sleeping body is waiting for. All of this is happening right now in the background of this story if you drank something warm before you began. The chemistry does not need your conscious attention to work. It is already working. The body knows what to do with what it has been given. It always has. Before the milk was in the glass, it was in the cow. And before it was in the cow, it was in the grass. And before it was in the grass, it was in the sunlight falling on a field somewhere in the early morning. This is where milk actually begins. A dairy cow grazes for 6 to 8 hours each day. She moves across the pasture in the unhurried, methodical way of a large animal that has all the time the field allows, pulling grass with her tongue, chewing with the steady, rhythmic motion that her 4-chambered stomach requires before the fermentation process that will extract every available unit of energy from the fibrous plant material can begin. She is not in a hurry. The grass is there and the day is long, and her body knows exactly what to do with what she is eating. The rumen, the first of the cow's 4 stomach chambers, is a fermentation vat the size of a large suitcase. Inside it, billions of microorganisms break down the cellulose in the grass, releasing nutrients the cow's own enzymes could never access directly. The grass, which seems like a simple food, becomes inside the rumen a complex chemical process. Fibers splitting into sugars, sugars fermenting into fatty acids, proteins being assembled and reassembled by microbial communities that have been living in close relationship with their bovine hosts for as long as cattle have existed. The energy and nutrients extracted from this process enter the cow's bloodstream and travel to the mammary gland where the milk is made. The mammary gland is extraordinarily active tissue, gram for gram, one of the most metabolically demanding organs in any mammal. It pulls glucose, fatty acids, amino acids, and minerals from the bloodstream, and assembles them according to a genetic program refined over millions of years, and into the precise composition that her calf will need. A high-producing dairy cow makes upward of 30 litres of milk each day. The energetic cost of this is enormous. She must eat continuously simply to maintain what her body is producing. What she eats shapes what the milk becomes. The fatty acid profile of milk fat is directly influenced by the cow's diet. Grass-fed cows produce milk with higher levels of omega-3 fatty acids and conjugated linoleic acid, compounds with their own beneficial roles in human health, because these compounds are present in fresh grass and are incorporated into the milk fat as the cow digests them. The milk from a cow eating spring grass in a green field is measurably different in composition from the milk of a cow eating a grain-based indoor diet. The field is present in the glass, and the season is present in the glass. The particular chemistry of the pasture, the soil, the rain that fell on it, the sunlight that grew the grass, all of it is transformed through the extraordinary biological machinery of the grazing cow into the white liquid cooling slowly on the counter. There is something deeply calming about tracing this chain from beginning to end. from the photons of sunlight absorbed by a blade of grass on a wet morning, to the glass in a dark kitchen at night. A journey that passes through soil and chlorophyll and cow and fermentation, and a mammary gland working at full capacity in the pre-dawn hours of a farm that has been doing this in one form or another for 10,000 years. Each step is patient. Each step is slow. Each step requires the previous one to be complete before it can begin. The sunlight became grass. The grass became energy. The energy became milk. The milk became the thing in the glass that is already, gently and without being asked, helping your body slow down. Nothing in this chain was rushed, and nothing about tonight needs to be either. Take one drop of milk, a single drop, the kind that falls from the lip of a glass and lands on the kitchen counter and sits there, perfectly round, catching the small light above the stove. That drop contains a universe, not metaphorically, in the scientific sense of an almost incomprehensible complexity held within a very small space. A single drop of whole cow's milk, approximately 50 microliters, smaller than a grain of rice, contains somewhere in the range of 100 million fat globules, and each fat globule is a tiny sphere of fat surrounded by a membrane made of phospholipids and proteins, ranging in size from under a micrometer to nearly 20 micrometers across. They are so small that 10,000 of the smaller ones, lined up side by side, would span 1 centimeter. These fat globules are suspended in a watery phase that contains its own extraordinary architecture. The casein proteins do not float freely in the water. They self-assemble into structures called micelles, roughly spherical clusters, roughly 100 to 300 nanometers in diameter, in which case in proteins are arranged around a core of calcium phosphate. A micelle is not a fixed structure. It is a dynamic one, constantly exchanging material at its surface and held together by the balance of electrostatic and hydrophobic forces, rather than by any rigid bonding. Disturb that balance, change the pH, add heat, add acid, and the micelles rearrange. This is the chemistry behind yogurt, behind cheese, behind every transformation that milk can undergo. Between the fat globules and the calcium micelles, the drop of milk also contains whey proteins moving freely through the water phase, lactose molecules dissolved and invisible, calcium and phosphorus ions associated with the casein structures, a long list of hormones and growth factors in trace concentrations, and thousands of bioactive compounds in amounts so small they were undetectable until modern analytical chemistry developed the tools to find them. All of this is in stable suspension. This is the part that should not work as well as it does. Fat and water do not mix. This is a basic chemical fact, the reason that oil and vinegar separate in a bottle no matter how vigorously you shake them. And yet milk, which is roughly 4% fat dispersed in 90% water, does not separate under normal conditions. The fat globule membranes are the reason. They provide an emulsifying layer that keeps the fat dispersed, that prevents the globules from coalescing and rising to the surface. The membrane is a piece of biological engineering so effective that food scientists have spent decades trying to replicate it in artificial emulsions and have still not produced anything with quite the stability and functionality of the real thing. The drop also has a colour, and the colour is worth thinking about. Milk is white, not cream white or grey white or slightly yellow white, though fresh whole milk has a slight warm tone that skim milk lacks. White in the full optical sense. a surface that returns all visible wavelengths of light to the eye without preferential absorption of any of them. This whiteness is not produced by a pigment. Milk contains no white colouring. The whiteness comes from the fat globules and carcin micelles scattering light. All wavelengths, in all directions, equally. When you look at a glass of milk, you are seeing the collective light-scattering behaviour of hundreds of millions of tiny suspended particles. The colour is structural, not chemical. It is physics wearing the face of food. One drop, held together by forces too small to see, structured at scales too small to imagine, doing things that took millions of years of evolution to figure out, and decades of modern science to begin to describe. It sits on the counter, perfectly round, perfectly still, waiting, as it always has, to be useful. 10,000 years ago, somewhere in the region we now call the Fertile Crescent, the arc of land stretching from what is now Iraq through Syria and Turkey and down into the Jordan Valley, human beings did something that had never been done before in the history of the species. They kept an animal alive after they could have eaten it. The domestication of cattle is one of the most consequential decisions in human history, and it was not a single decision made by a single person. It was a gradual process, repeated independently across different regions over several thousand years. As people who had been hunting wild aurochs, the enormous, aggressive ancestor of modern cattle, began selectively keeping calves, taming them over generations, and eventually building their lives around the animals they had once only hunted. The first use of cattle was almost certainly for their meat and for the labour of large animals that could pull and carry. Milk came later, or perhaps alongside, as people discovered that a cow with a calf could also provide milk to people willing to be patient enough to obtain it. The earliest direct chemical evidence of dairying, milk fats preserved in ancient pottery, dates to around 9,000 years ago in what is now Turkey. By 8,000 years ago, dairying was established across much of the Fertile Crescent and was beginning to spread into Europe with the migrations of early farming peoples. But there was a biological problem. Adult mammals, under normal evolutionary circumstances, lose the ability to digest lactose, milk sugar, after weaning. The gene for lactase, the enzyme that breaks lactose into digestible simple sugars, is active in infants and is switched off as the animal matures, because there is no evolutionary reason for an adult mammal to digest milk. Adults do not drink milk. The gene is no longer needed. Then humans started drinking milk as adults. Among the populations that kept cattle intensively, a genetic mutation that kept the lactase gene active into adulthood, lactase persistence, provided a significant survival advantage. People who could drink fresh milk had access to a reliable, high-calorie, nutritionally dense food source that people without the mutation could not fully use. In environments where food security was precarious, this was not a minor advantage. It was potentially the difference between surviving a bad year and not. The mutation spread. It spread fast, in evolutionary terms. Within a few thousand years, lactase persistence was common in populations across northern Europe and in pastoral communities in Africa and the Middle East, where cattle keeping was central to survival. It is now present in the majority of people in these regions. Your ability to drink a glass of milk and feel the warmth of it moving into your body without digestive distress is, if you have it, a gift from ancestors who kept cattle in a world where that ability carried life or death weight. And for those whose genetics do not carry this mutation, the majority of the world's population concentrated in East Asia or parts of Africa, and communities where cattle keeping was not part of the ancestral lifestyle. The story is not one of lack, but of a different relationship. Fermented dairy, yogurt, kefir, hard cheese, has its lactose broken down by bacterial action, making it accessible regardless of lactase persistence. Every culture that encountered dairy found its own way to the part of it that their bodies could use. 10,000 years. From a wild aurochs in a Mesopotamian valley, to the domesticated cow on the farm, to the glass on the counter. A relationship that changed human genetics. That shifted the course of entire civilizations. That fed armies and sustained cities, and built some of the oldest trade routes in the world. All of it, at the end, coming to rest in a warm glass in a dark kitchen. The glass is older than it looks, and the dairy farm does not wait for the sun. Long before the sky has given any indication that dawn is coming, when the stars are still fully out, and the air is at its coldest, and the fields are completely dark, the first lights go on in the milking parlour. A dairy farmer's day begins in a darkness that most people associate with the middle of the night. And the reason is the cow. Her body runs on a hormonal clock that does not negotiate with human schedules. And the milk that has been accumulating in her udder since the last milking does not wait comfortably for much longer than 12 hours. The farm wakes when the cow needs it to. There is a particular quality to a dairy farm in the pre-dawn hours that is unlike any other time of day in any other place. The first sound you notice is the breath. So dozens of large animals in an enclosed space produce a collective warmth and a collective sound. Slow, measured exhalations that fill the air of the barn with a moisture and a heat that contrasts sharply with the cold outside. The breath of cattle in cool air is visible, small clouds rising and dispersing in the dark. Each animal breathes at her own rhythm, but the collective sound of many together creates a deep, irregular, deeply calming background that has no equivalent in the human world. The cattle move slowly in the pre-dawn. They are not agitated or urgent. They have been doing this their whole lives, and the routine is as familiar to their bodies as sleep. They walk the lanes between stalls with the calm, unhurried movement of animals that know where they are going and have been there many times before, or the sound of hooves on concrete. The low, occasional vocalizations, not calls of alarm or distress, but the quiet contact sounds that cattle use to maintain awareness of each other in low visibility. A steady, low murmur of an animal community going about its first business of the day. The milking equipment has its own rhythm. The pulsators that control the action of the milking cups produce a steady, repetitive sound. A soft, mechanical pulse, roughly 60 times a minute, that runs beneath the other sounds of the parlour. It is the heartbeat of the milking, regular and unvarying, and it synchronizes with the biological rhythm of the letdown reflex in the cow's udder, in a way that makes the whole process feel, despite the machinery, like something ancient and organic, which it is. The technology changes, and the relationship between the farmer and the animal, the care and the attending and the getting up in the dark, that part is 10,000 years old. The milk enters the collection line and moves through clear tubing toward the bulk tank, a large, cooled vessel that will hold it at 4 degrees Celsius until collection. Watching milk move through clear tubing in the early morning light of a milking parlour is one of the most quietly compelling sights in agriculture. White liquid moving steadily and silently through transparent pipes, warm from the cow and cooling as it goes, the colour of it more visible against the steel and glass of the modern parlour than in any other setting. By the time the sun appears at the horizon, the first milking is done. The cows file back to the pasture or the feeding area, their movement relaxed and familiar. The farmer begins the cleaning routines that will sterilize the equipment before the evening milking. The milk in the bulk tank is already cooling toward the temperature at which it will be collected, processed, and sent on the long journey toward the glass on the kitchen counter. The farm is already quiet again. The birds are beginning in the hedgerows. The fields are pale gold in the first light. It is barely 6 in the morning, and the milk has already been made. The moment warm milk enters the mouth, the body begins to respond. Not after digestion, not after the tryptophan has been absorbed and converted. Immediately, through receptors in the mouth and throat and esophagus that detect temperature, texture, and the specific chemical composition of what is arriving, and begin sending signals to the nervous system before the milk has even reached the stomach. The warmth is the first signal. The mouth contains thermoreceptors that register the temperature of incoming food and drink and relay that information to the brain. A warm liquid arriving into the mouth and throat activates a branch of the vagus nerve. The long, complex nerve that runs from the brainstem all the way down through the chest and abdomen, connecting the brain to the heart, the lungs, the stomach, and the gut. The vagus nerve is the primary highway of the parasympathetic nervous system, the system responsible for what physiologists call rest and digest, the biological counterpart to the fight or flight response. When the vagus nerve is activated by warmth arriving in the throat, it sends signals that slow the heart rate slightly, relax the smooth muscle of the digestive tract, reduce the production of stress hormones, and generally move the whole body system in the direction of calm. This is happening before a single molecule of tryptophan has been absorbed. The milk reaches the stomach, and the stomach responds to it differently than it responds to cold food or acidic food. Warm milk with its fat content slows gastric emptying, the rate at which the stomach contents move into the small intestine. This is not a bad thing at bedtime. Slow gastric emptying means the nutrients in the milk are released gradually and steadily over a longer period. The tryptophan, the casein peptides, the calcium, all of them enter the bloodstream in a slow, steady stream rather than a single flood. The body receives a long, quiet conversation rather than a short, loud announcement. And the fat content does something else too. Dietary fat in the gut triggers the release of cholecystokinin, a hormone that acts directly on the vagus nerve to produce feelings of satiety and relaxation. Cholecystokinin is one of the reasons a meal with good fat content leaves you feeling more satisfied and calmer than a fat-free meal of equivalent calories. Whole milk activates this response. Skimmed milk, with most of the fat removed, activates it much less. This is part of why people who drink whole milk before bed consistently report a fuller, warmer sense of calm than people who drink skimmed, and why the folk tradition almost always specified whole milk, even before anyone understood the mechanism. In the bloodstream, the tryptophan from the milk competes with other amino acids for transport across the blood-brain barrier. This competition is the key to a piece of nutritional wisdom that, counterintuitively, suggests that warm milk works best when consumed on its own, or with only a small amount of carbohydrate. A small amount of carbohydrate triggers insulin release, which directs the competing amino acids into muscle tissue and leaves tryptophan as the dominant amino acid in the bloodstream, increasing its share of the transport into the brain, and therefore increasing the amount of serotonin the brain can make from it. The glass of warm milk with a small biscuit, the cup of warm milk with a piece of toast, the folk wisdom that paired these things was not random. The carbohydrate clears the competition for tryptophan transport. The milk provides the tryptophan. The brain makes serotonin. The serotonin makes melatonin. The melatonin opens the door to sleep. The body is doing all of this right now in the background of this story. The vagus nerve is carrying its warm signal. The stomach is releasing its contents slowly and steadily. The tryptophan is moving toward the brain. Nothing needs to be managed. Nothing needs to be directed. The body has been doing this for as long as there have been mammals. It knows exactly where this ends. Skim a glass of whole milk and you remove roughly half its flavour. This is not a matter of taste preference or cultural conditioning. It is chemistry. The flavour compounds in milk. The hundreds of volatile aromatic molecules that give whole milk its particular round, warm, slightly sweet character are almost entirely fat-soluble. They dissolve in fat and are carried by fat and are released by fat as it melts against the warmth of the mouth. Remove the fat and you remove the medium that carries the flavour. What remains is nutritionally adequate and chemically accurate, but sensorially thin, the outline of a flavour rather than the thing itself. The fat in whole milk is a mixture of hundreds of different fatty acids, assembled into triglycerides and packaged into the fat globules we encountered in the architecture chapter. Different fatty acids contribute different things to the flavour. Short-chain fatty acids, butyric acid in particular, give milk its characteristic slight sweetness and the warm, round quality that distinguishes it from other white liquids. Medium-chain fatty acids contribute to the body and richness. Long-chain fatty acids are largely flavourless themselves, but affect the physical texture of the fat, its melting point, the way it coats the mouth, and releases its aromatic cargo. The aromatic compounds dissolved in this fat matrix include aldehydes, ketones, lactones, and a range of other volatiles, produced partly by the cow's own metabolism and partly by the microbial activity that begins the moment milk leaves the udder and encounters the complex microenvironment of the collection system. Fresh whole milk from a healthy cow, drunk within hours of milking, has a delicacy and a sweetness that commercially processed milk approaches, but cannot entirely replicate. Because processing, while essential for safety, introduces heat that modifies some of the more fragile aromatic compounds, and homogenization, while essential for shelf stability, breaks the fat globules into smaller particles that release their aromatics differently. None of this makes commercial whole milk a poor food. It remains one of the most nutritionally complete single foods available. But it is worth understanding what the fat is doing beyond its nutritional role, because it explains something about the experience of warm whole milk that purely nutritional accounts of it miss. When whole milk is warmed, the fat becomes more fluid, its aromatic cargo more mobile. The volatiles that carry the flavour are released more readily from warm fat than cold, which is why warm milk smells more intensely milky than cold milk, and why the flavour experience of warm, whole milk has a completeness that cold skimmed milk cannot approach. And the warmth is not just delivering a comforting temperature. It is unlocking the fat's flavour chemistry, releasing the aromatics that the brain and the body associate at the deepest level of sensory memory with nourishment and safety. The body recognizes warm, fat-rich milk not just intellectually but sensorially, through smell, through the feel of it in the mouth, through the way the fat coats and lingers. These are not trivial sensations. The olfactory system connects directly to the limbic system, the part of the brain responsible for emotion and memory, bypassing the cortical processing that most sensory information requires. The smell of warm milk goes straight to the emotional brain, not through analysis, through recognition. Something in the body knows this smell, and something very old and very quiet responds to it, not as information to be processed, but as a signal already understood. The fat carries the flavour carries the memory, and the memory carries you home. A newborn calf stands within minutes of birth. This is not remarkable by bovine standards. It is the norm, as it is the norm for most large herbivores whose survival depends on being mobile quickly in a world where predators are real and the mother cannot carry her young to safety. But watch a newborn calf in its first hour, and what you see, beyond the mechanics of getting upright on legs that are still uncertain, is something quieter and more fundamental. Within those first minutes, the calf is searching. Its head moves, its nose works. It is looking for something specific, guided by a neurological program older than the species itself. It is looking for the first milk. The first milk a newborn mammal receives is not ordinary milk. It is colostrum, a different fluid entirely, thick and yellow gold, produced by the mammary gland for the first few days after birth, before the composition shifts to the milk that will sustain the young animal for the months ahead. Colostrum is essentially a concentrated immunological gift, extraordinarily high in antibodies, in growth factors, in white blood cells transferred directly from the mother's circulation. It is not primarily food, it is medicine. It is the mother's immune history, packaged and delivered in the first hours of her young one's life, providing a degree of protection that the newborn's own immune system will not be able to generate for weeks. But it is more than immunology. Colostrum and the milk that follows it contain hormones that act directly on the newborn's developing nervous system. Opioid-like peptides, the same casein-derived compounds we encountered in the sleep chemistry chapter, are present in significant concentrations and act on the brain's reward system, producing a response that is calm, satisfied, and bonding-oriented. The calf nursing is not only taking in calories and antibodies, it is receiving a neurochemical signal that says, "This is safe. This is the center of the world. Stay here." The mother's oxytocin, released during nursing, is mirrored by oxytocin release in the calf. Oxytocin is the bonding hormone, the same molecule released during human touch, during eye contact between parent and infant, during moments of deep social connection. Nursing floods both animals with it simultaneously. The bond being formed is not social learning or habit. It is being written directly into the neurochemistry of both animals, in the same biochemical language the mammalian nervous system has used for this purpose for 300 million years. The calf drinks. The warm milk moves into the rumen, the opioid peptides reach the brain, the oxytocin peaks, the calf's head drops, the legs fold, and the animal that was searching and uncertain 15 minutes ago is now asleep in the straw, pressed against the warm flank of its mother, as completely at rest as any living creature can be. The human infant follows the same script in its own version. The nursing hormones, the casein peptides, the oxytocin, the warmth, and the smell of the mother's skin, all of it combining into the most complete experience of safety and satiation the body will ever receive. The neurological imprint of this experience does not disappear when childhood ends. It is not overwritten. It is filed in the deepest part of the body's memory system, below language and conscious recall, in the place where the body stores its oldest knowledge of what safe feels like. This is why the warm glass of milk at night touches something that logic alone cannot reach. You are not simply drinking a food that contains useful nutrients. You are sending the body a sensory signal that it filed once at the very beginning under the heading of completely, utterly, unconditionally safe. The body does not need you to explain this to it. It remembers on its own. It has always remembered. Milk is white, and this seems like the least interesting thing you could say about it. So obvious, so unremarkable, such a basic visual fact that it barely registers as something worth examining. And yet, the whiteness of milk is one of the most quietly fascinating things about it, because it is not what it appears to be. There is no white pigment in milk, no molecule, no compound, no chemical constituent of milk is white. The fats are pale yellow, tinted by the carotenoid pigments from the cow's grass diet, which is why butter, made by concentrating the fat, has that characteristic warm yellow colour, and why whole milk has a very slightly warmer tone than the pure optical white of skimmed milk, from which the fat has been removed. The proteins are colourless, the lactose is colourless, the water is colourless. There is nothing in milk that, examined in isolation, would produce the colour white, and yet milk is white, vivid, complete, full spectrum white. The whiteness is made by physics rather than chemistry. When light strikes the surface of a glass of milk, it encounters hundreds of millions of tiny particles, the fat globules and the casein micelles suspended throughout the liquid. Each of these particles is small enough that light waves interact with it through a process called scattering, rather than simple reflection. Scattering sends the light off in all directions, at all angles, rather than bouncing it back in the organized way that a mirror or a painted surface does. And crucially, as the fat globules and casein micelles scatter all wavelengths of visible light with roughly equal efficiency, they do not preferentially scatter red light or blue light or any other color. They scatter everything equally in all directions. When all wavelengths of light are scattered equally in all directions, the eye receives them all simultaneously, and the brain interprets the combination as white. The same physical principle makes clouds white. The water droplets in a cloud scatter all wavelengths of sunlight equally, producing white from colourless water and colourless air. Milk and clouds are white for exactly the same reason. Both are made of tiny suspended particles scattering light that contains all colours into an equal, directionless scatter that the eye reads as the absence of colour preference, so which is the definition of white. This means that the whiteness of milk is not a property of the milk itself. It is a property of the interaction between milk and light. In the dark, milk is not white. It is nothing, visually, like everything else in darkness. The whiteness only exists when light arrives and the particles scatter it. The colour is created in the meeting between the liquid and the light, not in the liquid alone. There is something in this that is worth sitting with. The most iconic visual quality of the most universal food. The whiteness that makes milk immediately recognizable from any distance, that has made it a symbol of purity and nourishment across virtually every culture that has encountered it, is not intrinsic to the substance. It emerges from the encounter with light. The milk does not contain whiteness. The milk produces whiteness when light meets it through the collective behavior of hundreds of millions of particles doing what particles do. Skim milk is whiter than whole milk. This seems counterintuitive until you understand the mechanism. Removing the fat removes the yellow carotenoids that slightly warm the color of whole milk and the smaller, more uniform casein micelles that remain scatterlight even more efficiently than the mixed-size particle population of whole milk. The result is a more purely optical white, a brighter, cooler, slightly artificial-looking white that reads as whiter than whole milk to the eye, even though it contains less. The richest, most nourishing version is the slightly warmer one. It always is. Somewhere in a cave in the mountains of southern France, a wheel of Roquefort is aging in the dark. It has been there for months. It will be there for months more. The temperature in the cave is a constant 8 degrees Celsius. The humidity, nearly 100%. The air moving through ancient fissures in the limestone in slow, continuous currents that have been blowing through the same passages for millennia. The cheese does not know it is in a cave. The cheese does not know anything but the bacteria and the molds working through it. Penicillium roqueforti, threading blue-green through every crack and pocket of the interior, are doing what they have always done in these conditions, slowly and completely transforming the substance that the milk once was into something it could never have become on its own. Cheese is what happens when you give milk to time. And the basic chemistry of cheese making is ancient, and was almost certainly discovered by accident, as most of the great culinary discoveries were. Milk stored in a pouch made from a calf's stomach, which contains the enzyme renin, curdles and separates into solid curds and liquid whey. The curds, pressed and salted, last far longer than fresh milk. The discovery that renin caused this transformation, and that the resulting solid could be aged and preserved and transported and traded, was one of the earliest instances of humans using a biological process they did not understand to produce a food they valued enormously. The renin, or rennet, disrupts the casein micelles we have already spent time with, those extraordinary protein structures that hold calcium and phosphorus in suspension, that give milk its smooth, uniform character, that are so stable they can survive being shaken and heated without losing their fundamental architecture. Rennet dismantles them. Specifically, it cleaves a portion of the casein protein on the micelle surface, removing the part that keeps the micelles from sticking together. Without that protective surface chemistry, the micelles aggregate. They clump, they tangle, they form a three-dimensional gel network that traps fat globules within it and excludes the watery whey phase. The gel is the curd. Cut it, cook it, press it, salt it, and you have a young cheese. Mild, moist, rubbery. Already something milk could not be, but cheese can. And then the waiting begins. Aging cheese is one of the most patient acts in food production. The microbial communities working through the cheese. Bacteria producing lactic acid, bacteria producing flavor compounds, molds producing enzymes that break down proteins and fats into their flavorful constituent parts. Work at the pace that temperature and humidity allow, which is deliberately, in great cheese caves, a very slow pace. The enzymes that break down the milk proteins during aging produce hundreds of flavor compounds that were not present in the original milk. Aged cheddar contains pyrazines, nutty, roasted notes. Parmesan contains glutamates in concentrations that rival soy sauce, the deep, savory intensity that makes it so irreplaceable. Brie contains ammoniacal compounds that give it its particular pungency, produced by bacterial activity at the rind working inward. None of these flavors existed in the milk. They are created by time and microorganisms and the particular chemistry of breakdown and transformation. The cheese that takes the longest to make carries the most complexity, the most depth, the most layers of flavor, because it has had the most time for transformation to work. Patience, applied to milk, makes something that milk alone cannot be. The cave is dark and cool and completely still. The cheese wheel does not move. The molds thread their slow blue lines through the interior. The months pass without drama, without urgency, without any sign that anything of consequence is occurring. And then the cave door opens, and the wheel comes out into the light, and what it has become, through nothing but time and cold air, and the invisible patient work of living organisms, is extraordinary. Transformation does not always announce itself while it is happening. Sometimes it only becomes visible at the end. Between the farm and the glass, milk travels an invisible road. It is a road made not of asphalt or concrete, but of temperature, a continuous, carefully maintained cold corridor that begins the moment milk leaves the cow's body and does not end until the moment the carton is opened in your kitchen. This road has a name. The people who manage food systems call it the cold chain. And it is one of the most significant pieces of invisible infrastructure in modern life. A network of refrigeration, insulation, monitoring, and logistics that most people never think about, that runs silently beneath the ordinary act of pouring milk into a glass. Milk is vulnerable. At room temperature, the bacteria that exist naturally in even carefully handled fresh milk double their population approximately every 20 minutes. A litre of milk left on a warm counter for 6 hours carries a bacterial load thousands of times higher than the same milk kept cold. The flavour degrades. The proteins begin to break down. The fat begins to oxidize. What was, in the morning, a fresh and nutritionally complete food becomes, by evening, something the body would be right to object to. Cold stops this. Not completely. Refrigeration slows bacterial reproduction dramatically, but does not halt it, which is why milk has a finite shelf life, even in a refrigerator. But slowing the process enough, and maintaining that slowing continuously throughout the chain from farm to consumer, is what makes fluid milk a safe and reliable food at population scale. The bulk tank on the dairy farm is the first link. Raw milk from each milking is cooled to 4 degrees Celsius within 2 hours of collection, a rate of cooling specified by food safety regulations in virtually every country that produces commercial milk. The tank is insulated and refrigerated, and an agitator stirs the milk slowly to ensure even cooling throughout the volume. Temperature sensors log the milk's temperature continuously, creating a record that can be reviewed if any question arises about the handling of a particular batch. The collection truck arrives on a schedule, every day or two, depending on the farm's output. With a stainless steel tanker that is itself refrigerated and insulated. The milk is pumped from the farm's bulk tank into the tanker. The temperature is checked and recorded, and the truck begins its route in collecting from multiple farms before delivering to the processing facility. The tanker keeps the milk cold throughout the journey. By the time it arrives at the processing plant, the milk has been cold continuously since it left the cow. At the processing plant, the milk is pasteurized, heated briefly to a temperature high enough to kill pathogenic bacteria, then cooled again immediately. The heating lasts seconds. The cooling is rapid. The cold chain resumes the moment pasteurization is complete, and does not break again through bottling, through warehouse storage, through refrigerated transport to distribution centers, through refrigerated delivery to shops, through the refrigerated display case where the carton sits until someone picks it up. The cold chain is a triumph of applied physics and logistics that most people in the developed world take so completely for granted that it is invisible. The milk in the glass arrived cold because an unbroken sequence of refrigerated environments carried it without interruption across potentially hundreds of kilometers and several days. The carton on the shelf is the visible end of a journey whose infrastructure cost billions of dollars and required decades of engineering development to make reliable. Behind every ordinary glass of cold milk is an extraordinary system that nobody sees. It works so well, so quietly, so completely that it has become part of the background of daily life, as invisible and as essential as the pipes that carry water or the wires that carry electricity. The milk is cold, the chain held. It always does, and the world is large, and the animals in it are varied, and the people who live alongside those animals have found, in almost every case, a way to make use of their milk. On the steppes of Mongolia, a herder's family keeps a herd of mares, and, in the warm months when the mares are lactating, collects their milk and ferments it in a large leather bag hung near the entrance of the ger. The bag is struck by every person who passes in and out during the day. A casual, habitual blow that agitates the contents and keeps the fermentation moving. Over days, the mare's milk transforms into airag, a mildly alcoholic, slightly fizzy, sour, and deeply nutritious drink that has been a dietary cornerstone of the nomadic peoples of Central Asia for at least 3,000 years. The milk of the horse, which has a different protein structure and a higher sugar content than cow's milk, ferments into something that cow's milk cannot quite replicate. The horse and the steppe and the leather bag and the accumulated microbial wisdom of generations of herders produce something specific to that place, that animal, and those people. In the deserts of Arabia and the Sahara, camel milk has been a survival food for nomadic communities for millennia. Camels can produce milk under conditions of heat and water stress that would stop a dairy cow's production entirely. Camel milk is lower in fat than cow's milk, but higher in vitamin C. Significant in a desert environment where fresh plant foods are scarce. It stays fresh longer in heat than cow's milk, partly due to natural antimicrobial proteins. And the Bedouin and the Tuareg and the Somali pastoralists, who have kept camels for thousands of years, knew all of this empirically, long before any food scientist confirmed it analytically. They knew it because they had lived it and staked their survival on it across many generations. In the Himalayan plateaus of Tibet and Nepal, yak milk, richer in fat than cow's milk, adapted to the cold, thin air of high altitude, is made into butter that is churned into the salted butter tea that provides calories and warmth through winters that can kill without it. The butter is also formed into blocks and stored for months, an ancient preservation strategy that concentrates the milk's fat and strips away the water that makes fresh milk so vulnerable to spoilage. So yak butter tea, po cha, has a taste that people raised outside the Himalayan tradition frequently find confronting on first encounter. To the Tibetan body that grew up on it in a cold climate where every calorie matters, it is comfort, warmth, and home in a single cup. In India, buffalo milk, higher in fat and protein than cow's milk, is the raw material for paneer, the fresh cheese that appears in hundreds of regional dishes, and for ghee, the clarified butter made by simmering butter until the water evaporates and the milk solids brown and are removed, leaving behind a pure, shelf-stable fat with a rich, nutty flavour that is used across the subcontinent as both cooking medium and sacred offering. Ghee is mentioned in the Rig Veda, one of the oldest texts in any Indo-European language, as a gift to the gods. And the relationship between people and their milk animals in India is among the oldest and most culturally embedded of any in the world. In the mountain pastures of France and Italy and Spain and Greece, sheep and goat milk become cheeses of extraordinary character. Pecorino, Manchego, Roquefort, Feta, each one shaped by the specific grasses and herbs of the pastures where the animals graze, the specific bacterial cultures of the local environment, the specific traditions of the cheesemakers, whose knowledge often goes back centuries. The milk of the sheep on a particular hillside in Sardinia, made into pecorino by the same methods used there for 2,000 years, tastes specifically of that hillside. The place is in the cheese. Every culture that found milk found its own relationship with it. Every relationship produced something that the others did not, could not, in the same way. The diversity of dairy across human cultures is not a list of variations on a single theme. It is a collection of independent discoveries of the same fundamental truth, expressed in the language of each specific place, each specific animal, each specific people. Milk, it turns out, speaks every language. It has always known how to make itself at home. The skeleton of an adult human contains approximately 1 kilogram of calcium. This is easy to think of as a static quantity, a fixed deposit of mineral in the bones, put there during childhood and adolescence, when the skeleton was growing and drawing heavily on dietary supplies, now stable and largely inert. The calcium in the bones as finished structure, like concrete in a wall that has already set. And this picture is wrong in ways that matter. Bone is not an inert structure. It is living tissue, constantly being remodeled by two populations of cells working in opposition. Osteoblasts, which build new bone tissue, and osteoclasts, which break down existing bone tissue and release the minerals back into the bloodstream. This remodeling process runs continuously throughout life, replacing the entire skeleton approximately every 10 years in adults. Bone that was there a decade ago is gone. The skeleton you will have in 10 years is being built right now, from the calcium circulating in your blood today, which came, if you are eating a typical diet, substantially from dairy foods. But calcium does not stay in the bones. It moves constantly between bone, blood, and the interior of cells, managed by hormones, primarily parathyroid hormone and calcitonin, that maintain blood calcium within an extraordinarily narrow range. Too high, and it disrupts the electrical signaling of nerve cells. Too low, and the effects are more immediate and more dangerous. Muscle cramps, irregular heart rhythm, in severe cases, seizure. The body guards its blood calcium level with the same precision it guards its blood, PaPH, because both are conditions on which everything else depends. In nerve cells, calcium is the messenger that carries signals across the synapse, the gap between one neuron and the next. When an electrical signal reaches the end of a nerve fiber, it triggers the opening of calcium channels in the cell membrane. Calcium floods in. The influx of calcium triggers the release of neurotransmitter molecules, serotonin, dopamine, norepinephrine, GABA, into the synapse, where they carry the signal to the next cell. No calcium influx, no neurotransmitter release, no signal. Every thought you think, and every feeling you have, and every movement your body makes is mediated by calcium moving through channels in nerve cell membranes. In muscle cells, calcium is the trigger for contraction. When a nerve signal arrives at a muscle fiber, it causes calcium to be released from storage inside the cell. The calcium binds to proteins in the muscle fiber and initiates the mechanical process of contraction, the sliding of protein filaments that shortens the fiber and generates force. When the signal stops, the calcium is pumped back into storage and the fiber relaxes. Every heartbeat, every breath, every step is calcium leaving and returning to storage inside muscle cells, over and over, all day, all life. The heart muscle is the most critical case. The cardiac muscle cells that contract with each heartbeat are exquisitely sensitive to calcium concentration. The rhythm and strength of the heartbeat are directly regulated by the amount of calcium available to enter the cardiac muscle cell during each contraction cycle. This is why extreme calcium deficiency produces cardiac arrhythmia. The heart's rhythm becomes unreliable when the calcium signal that drives it is disrupted. Every glass of milk contains around 300 milligrams of calcium, roughly 30% of the daily requirement for an adult. In the form of calcium phosphate bound within casein micelles, the most bioavailable form in which dietary calcium can be delivered. So the casein protein structure that carries this calcium into the body was, as we noted much earlier in this story, a solution to the problem of keeping calcium in solution and getting it into the bloodstream, rather than having it crystallize in the gut and pass through unabsorbed. The glass on the counter is doing all of this. The nervous system, the heartbeat, the muscle contraction, the bone maintenance, the synaptic transmission. The calcium in that glass is the architecture of the working body. Sip by quiet sip, the body is maintained. It has always been this way. There is a specific quality of light in the early morning that exists nowhere else in the day. It arrives tentatively. It does not announce itself. Before the sun has cleared the horizon, before the sky has committed to the particular blue of a clear day or the grey of an overcast one, there is a period of light that is neither day nor night, a pale, directionless illumination that seems to come from everywhere and nowhere at once. That gives familiar objects unfamiliar edges and makes everything look slightly newer than it usually does. In this light, a glass of cold milk on a kitchen counter looks like something painted, the white of it against the pale morning grey. The condensation beginning to form on the outside of the glass where the cold surface meets the warming air of the kitchen. The way the early light catches the surface of the milk and returns it softly, without the sharp reflections of midday. A gentler brightness, a colour that is white but barely, warm but barely, present but barely. The way everything in the early morning is barely but fully itself. The first glass of milk of the day arrives into a body that has been fasting for 6 to 8 hours. The stomach is empty. The blood sugar has dropped to its overnight low. The digestive system, which was running in low gear through the night, is ready to begin. And what it receives in that first morning glass is, in some ways, the most efficiently used milk of the entire day, absorbed into a system that is ready for it, processed by a gut that has been resting and is now available, distributed to tissues that have been waiting through the night for new material to work with. The morning glass has a different character from the evening glass, and not only biochemically. There is a ritual dimension to the first food of the day that the last food of the day does not have in the same way. The evening glass is an arrival, the end of the day's demands, the beginning of the body's rest, the closing of one thing and the opening of another. The morning glass is a beginning, the first thing the body receives in the new day, the first signal that the world is again available, the small, reliable anchor that makes the day feel like it has started on solid ground. People who have strong morning routines, who have, through habit and repetition, built the first hour of the day into a reliable sequence, often describe the comfort of those routines in terms that have nothing to do with their content. It is not that coffee is magical, or that a particular breakfast is objectively superior to all alternatives. It is that the familiarity is comforting. The repetition is settling. The body knows what is coming and relaxes into the knowing. Milk has been part of the morning ritual of human beings since there have been domestic animals to milk. The morning is when the milking happens. It has always been when the milking happens, because the animal's body has accumulated milk through the night, and the morning milking is both practical and necessary. The fresh milk of the morning has been the first food of millions of people across thousands of years of agricultural life. The body's association between milk and morning beginnings is, like so many of its associations with milk, older than any individual life that carries it. The light outside is changing. The pale grey of early morning is warming, slowly, as toward the yellow-white of the day's first proper sunlight. The kitchen is becoming more itself. The familiar geography of the room is sharpening as the light grows. The corners coming clear, the colours finding themselves. The glass is cold, the milk is white. The morning is beginning the way mornings always begin, quietly and without drama, the world returning to itself after the night. Small, reliable, enough. It has always been enough. Before refrigeration, milk did not wait. In the warm climates of the ancient Mediterranean, the Middle East, and South Asia, fresh milk left in a vessel at room temperature would begin to ferment within hours. The bacteria present on every surface, in the air, on the vessel, in the milk itself, would consume the lactose and produce lactic acid as a byproduct. The pH would drop. The casein micelles, unstable in the neutral pH of fresh milk, would begin to aggregate as the acid dismantled their surface chemistry. The milk would thicken, curdle, and sour. And the people who experienced this discovered something important. The soured milk was still edible. More than edible. It had qualities that fresh milk did not. It was thicker and more satisfying. It lasted longer before it became unsafe. And over time, as specific bacterial cultures were preserved and reintroduced, a spoonful of yesterday's yogurt stirred into today's warm milk, generation after generation. The fermented dairy products developed consistent, reliable, enjoyable flavors that people learned to value and seek out. Yogurt, kefir, labne, filmjölk, vili, crème fraîche, cultured buttermilk. The fermented dairy traditions of the world are as diverse as the dairy traditions of the world. And they developed independently in cultures separated by thousands of miles. Because the same discovery was available to any person who kept milk animals and lived somewhere warm. Milk ferments. Fermented milk keeps. Fermented milk feeds the gut differently than fresh milk. The discovery was made again and again, each time producing a slightly different version depending on which bacteria were present in the local environment, which animals provided the milk, and what the ambient temperature encouraged. The bacteria doing this work belong primarily to a family called lactic acid bacteria, a broad group that includes the Lactobacillus and Streptococcus species used in most yogurt cultures, and the more complex communities of organisms in kefir, which contains not only bacteria, but yeasts, and produces a slightly fizzy, mildly alcoholic fermented milk that has a microbial diversity closer to a healthy human gut microbiome than almost any other food. And the gut is exactly where fermented dairy does its most significant work. The human gut microbiome, the community of trillions of microorganisms that live in the large intestine and influence everything from immune function to mood to the metabolism of drugs, is maintained partly by the foods that pass through it. Fermented dairy provides live bacterial cultures that, while they do not permanently colonize the gut in most cases, pass through it and have measurable effects on the existing microbial community during their transit. They compete with pathogenic bacteria. They produce compounds, short-chain fatty acids, B vitamins, certain neurotransmitter precursors, that the gut lining and the host body use. They modulate the immune response of the gut-associated lymphoid tissue in ways that reduce inflammatory signaling. The gut is also, in a sense that is only beginning to be properly understood, a second brain. The enteric nervous system, the network of neurons embedded in the gut wall, contains more neurons than the spinal cord and communicates with the central brain via the vagus nerve in both directions, sending signals upward that influence mood, anxiety, and sleep quality. The gut microbiome influences the enteric nervous system, which influences the vagal signals to the brain, which influences how you feel. Fermented milk, given to the gut, influences the community of organisms that influence the network of neurons that communicate with the brain that is trying tonight to slow down and sleep. The bowl of yogurt at dinner, the glass of kefir in the evening, the ancient practice of preserving milk through fermentation, developed independently across dozens of cultures, across thousands of years. It was not only about keeping milk edible in a warm climate without a refrigerator. It was also, it turns out, about the quiet management of a nervous system that needs, tonight as every night, to find its way to rest. The living milk is still working, even now, even here, even as you slow. There is a category of memory that exists below language. Psychologists and neuroscientists call it implicit memory, or sometimes procedural memory or sensory memory, the kind of knowing that lives in the body rather than in words. It is the memory that guides your hand to the light switch in a dark, familiar room, without your having to think about where the switch is. The memory that makes a particular song stop you mid-step, because it carries the feeling of a specific afternoon you haven't consciously thought about in years. The memory that lives in the smell of a particular food, in the texture of a particular fabric, in the weight of a particular kind of object in the hand. This memory is not stored in the hippocampus, the brain structure associated with the conscious recall of events and facts. It is stored more broadly, in the cerebellum, in the basal ganglia, in the amygdala and the limbic system, in the sensory cortices that process the original experience. It is laid down earliest and most durably. It does not require repetition to form. A single sufficiently strong sensory experience can encode itself so deeply that decades cannot fully erase it. And it is not retrieved by thinking. It is retrieved by encountering the original sensory trigger again. The smell of warm milk is one of the earliest sensory experiences encoded in the human nervous system. Before visual memory is reliable, and in human infants, it takes weeks before visual acuity is sufficient to form lasting visual memories. Smell is already fully functional. The olfactory system is the most ancient and most directly wired of the human senses. Where other sensory information travels through a relay station in the thalamus before reaching the cortex, the smell travels a more direct route, from the olfactory receptors in the nose to the olfactory bulb to the limbic system, the emotional center of the brain, with minimal cortical processing required. The emotional weight of a smell is felt before it is understood. Before the brain has identified what is being smelled, the limbic system has already assigned it a feeling. The first smell that most human infants encounter is the smell of the mother's skin and colostrum. Warm, fatty, slightly sweet. This smell is present at every nursing, which is every few hours for the first weeks of life. It is associated, through direct experience, with the alleviation of hunger, with warmth, with physical contact, with the neurochemical flooding of opioid peptides and oxytocin that nursing produces. It is encoded, so over hundreds of repetitions in the earliest and most neurologically plastic period of life, as the smell of everything being all right. The smell of warm milk is not identical to the smell of colostrum or the smell of human breast milk. But the overlapping chemical families, the warm volatiles from heated fat, the slight sweetness of lactose, the particular character of heated milk protein, are similar enough that the olfactory system registers a family resemblance. Something in the nose signals a similarity to the oldest smell it knows. Something in the limbic system responds with a recognition that is not conscious and does not need to be. This is the mechanism behind the comfort of warm milk in adulthood. Not nostalgia in the sentimental sense, not a conscious reaching back toward a remembered childhood, but something older and less voluntary. The smell arrives. The limbic system processes it against its archive and finds a match that goes back further than any conscious memory reaches. The feeling that follows is not manufactured or chosen. It is retrieved. The body is not pretending to be comforted. It is being comforted by the same signal it was comforted by at the very beginning, in a response so deep and so automatic that neither the passage of time nor the full development of the adult brain has changed it. The body holds the oldest memories in the quietest places. It does not advertise them. It does not explain them. It simply responds when the right signal arrives, with what it has always felt in the presence of that signal. Warmth, safety, the particular piece of a body being given exactly what it needs. So the smell of warm milk is not a memory. It is a return. We started this story here. The dark kitchen, the small light above the stove, the wooden counter cool under a hand, and on it a glass of warm milk, steam rising slowly, catching the light in a thin curl and disappearing into the dark air above. You were looking at it then as an ordinary thing, a familiar object in a familiar room, something so common and so unremarkable that the eye passes over it without registering it as worthy of attention. A glass of milk. What could there be to say about a glass of milk? Look at it again now. Inside that glass is a solution of hundreds of compounds, assembled by a body that spent millions of years learning how to assemble them. All the carcine micelles are in there, those extraordinary protein structures that carry calcium and phosphorus in a form the gut can actually absorb, that scatter the light falling on the glass into the white you see, that will unfold in the stomach and yield peptides that whisper to the brain's calm receptors before the rest of the digestive process has even properly started. The fat globules are in there, each one a sphere of mixed fatty acids wrapped in a membrane that took evolution an enormous amount of time to perfect, carrying the aromatic compounds that give the milk its flavor and the fat-soluble vitamins that the body is waiting for. The tryptophan is dissolved in the watery phase, moving freely, beginning already to be absorbed through the stomach wall and making its way toward the blood and the brain where it will become. In the hours ahead, the melatonin that will complete what this night has been moving toward all along. The warmth is already in you if you drank it. The vagus nerve has already received its signal. The core temperature has risen its small amount and is already beginning its slow descent. The physical drop that the body reads as permission. The cooling that every mammal's sleeping body performs as part of the preparation for rest. The chemistry is already running. The body has already started. It does not need you to manage it. It has been managing itself with far greater precision than you could consciously direct, since the moment the first warm mouthful crossed the threshold. 10,000 years of dairy farming are in that glass. The grass of a specific field, the sunlight of a specific season, and the body of a specific cow who ate and fermented and assembled. The cold chain that carried the milk unbroken from the farm. The ancient bacterial wisdom of fermentation. The genetic mutation that spread through populations of cattle keepers because it was so useful for staying alive. The people who carried that mutation forward to you through every generation between the first herders of the Fertile Crescent and the particular people who made you. The calf nursing in the first hours of its life is in that glass. The newborn's heavy sleep after feeding is in that glass. Every infant that has ever fallen asleep in the warmth and fullness of being fed is in that glass. The body's oldest memory of safety is in that glass. It is not a glass of milk. It is a glass of everything milk has ever been. Every relationship, every body, every field, every cold morning and warm kitchen and sleeping child and patient cow and ancient herder and mountain cave and turning wheel of cheese. 10,000 years of human beings and the animals they kept and the liquid those animals produced and everything that liquid carried and fed and comforted and sustained. All of it in a glass on a dark kitchen counter, steam rising, waiting. The kitchen is dark now. The small light above the stove has been enough for this whole story, and it is still on, still casting its particular limited warmth across the counter, across the wooden surface, across the glass that is empty now, or nearly so. The steam is gone. The warmth that rose from the surface of the milks when it was poured has moved into the room, into the air, into you. Because warmth is not lost, it is only transferred. And what was in the glass is now in the body that received it. The tryptophan is in the blood. The casein peptides have found their receptors. The calcium has joined the vast, slow circuitry of the body's mineral management. The bones and the blood and the nerve cells all drawing on the same pool, all maintained by the same quiet, continuous, unconscious process. The vagus nerve received its signal hours ago. The parasympathetic system has been running its slow, complete work since then, steadily moving the body away from the alertness of the day and toward the stillness the night is asking for. You have been on a long journey tonight. You went back to the beginning, to the first food, the original warmth, the thing the body knew before it knew anything else. You went into the chemistry that makes warm milk work and found that it works because it is genuinely, specifically designed to. Not designed by a person, not manufactured for a purpose. Designed by hundreds of millions of years of evolution, refined through 10,000 years of human relationship with dairy animals, embedded in the biological memory of every mammal that has ever nursed and slept and woken again. You learned that the whiteness of milk is made of light, not pigment. That the patience of fermentation transforms the ordinary into the extraordinary. That a calf knows, in its first minutes of life, exactly where to go and what it needs when it gets there. That the cold chain holds through the night so that the morning glass is safe. That somewhere in the mountains of southern France, a wheel of cheese is aging in the dark, patient and unhurried, becoming something that fresh milk could never be on its own. All of this lives in the glass. All of it is in you now. The body has done what it knows how to do. It received something warm and familiar and rich with the signals it has been recognizing since before it could form a thought. It processed those signals the way it always processes them, slowly, completely, without requiring your attention or instruction. The serotonin rose, the melatonin followed, the heart slowed its pace by a few beats per minute, imperceptible but real. The muscles, one group at a time, released a little of what they had been holding. You do not need to do anything now. The milk has done its part. The body is doing its part. What remains is the simplest possible thing, the willingness to let the night take over and to stop holding the day in place, to release the events and the thoughts and the plans and the half-finished sentences that the mind has been turning over and to let them go still, the way the surface of a glass of milk goes still when it is set down and left alone. The body knows how to sleep. It has been sleeping for your entire life, every single night. It does not need new instructions. It needs only the absence of interference, the small, quiet decision to stop directing and let the body lead. And if tonight's story helped you find that place a little more easily, there is one thing we would love before you go. Hit the like button. It takes 1 second, and it means the world to this channel. And subscribe if you haven't already, because tomorrow night we will be here again with another story built specifically for this hour, for this exact moment of the day when the body is asking for something quiet and the mind is finally willing to let it have it. Your spot will be here, the glass will be ready, but for now, the kitchen is dark and quiet. The light above the stove is still on, just enough to know where the walls are, just enough to make the dark feel safe. The milk is gone, the warmth remains. Sleep well.